All right, everybody, the break is over. Welcome back. Thank you all for continuing to join us this afternoon. We're now going to switch gears back to additional agency updates at the ground level, literally, with some updates from the teams developing surface EVA tools, XEMU exploration spacesuits, curation preparation, and astronaut training. Please remember to post your questions in the chat or the online tool, as Ryan has very conveniently posted again in the chat for easy access. We will address them at the end of this session in the 15-minute Q&A session at the end. A special thank you to Sarah, who will be driving our charts for us this round. She'll keep us all on track. And we will kick this last session off with an update on this wonderful Lunar Surface Science workshop series we've been hosting, no bias at all, from Dr. Kelsey Young. Kelsey, please take it away.
Okay, thanks, Deborah. So buckle up. Gonna have to summarize 8 full workshops in 10 minutes, so everybody get ready. So first, I'd like to thank the rest of the organizing committee who are listed here, without whom this would super not be possible. This is a massive lift and a big group effort. Thanks also to the LPI, especially Debbie Mitchell, who has been just a rock star with massive amounts of workload and registrants and helping troubleshoot IT issues. And lastly, but not least, thank you to Survey, who has helped obviously execute all of these sessions, and also the website where all of this great info will be posted, which I'll show you in a second. And actually, I'd also like to thank all of the session leads and early career facilitators that we've had. I'll give you shout outs on all of the relevant session slides, but thank you for your help. This would not be possible without you. And lastly, I want to thank all of you guys for attending and engaging in these workshops. Obviously, you found them because you're here today, but it really wouldn't have been possible without all of you guys attending and being willing not just to sit and listen, but present and engage in the breakout conversations. I did a quick calculation. We had 2,730 unique logins over the last 8 workshops. So we've been able to capture a great amount of community workshop feedback, and it's been really great. So next slide, please. So obviously you know what the LSSW series is because you're here today, but the intention was originally to gather in person in April of 2020. Due to COVID, we spun those off into a series of near monthly workshops. I'm going to step through a slide per workshop based on the discussions that all of you participated in. But the crux of the workshop series has been to gather community input and engagement early on in the integration of science into exploration to maximize science return from Artemis. Next chart, please. Each LSSW session has included a combination of invited talks, contributed talks from the community, breakout discussions with all of you guys, and in some cases, poster sessions. Critically, this is main takeaway today, each session has generated a report, all of which have been or is currently open for community comment for a period of a couple weeks before being finalized and posted online at the URL that's listed on this slide. The last 5 reports were just live this week, so you've got some homework to go on and make your comments to these critical reports, which will be delivered to headquarters and key program elements across Artemis. Next chart, please. Okay, here we go. So I'm going to summarize major takeaways from each of these LSSWs. These are pulled straight from the reports, and I've obviously had to cut down quite a bit to cover 8 workshops in 10 minutes. So I really encourage you to go to that URL and check out the reports for yourselves. Thank you to all the people listed on all of these slides who did the heavy lifting and prepping these reports. It's a really excellent resource that summarizes what the community thinks about these critical topics. So if you want to make input, now is the time to go make those comments. So for the first session, which was focused on EVA tools and instruments for doing surface science, the report and the workshop summarized key deployment styles for how in situ payloads would be deployed and key operational considerations that touch each one of those deployment styles. So you can see the ops considerations there on the right side. We basically mapped ops considerations for all of those deployment styles in that report. Next chart, please. The second session was on samples, and so some key takeaways from the report were key science questions that could be addressed with samples at a south circumpolar site that touched what you'd think of with local and regional geology comparison to Apollo sites and just what kinds of planetary science questions can be answered, as well as crater chronology, volatiles, and the unique lunar environment, which we've heard a lot about earlier today for our high-level Artemis objectives, while also touching on kind of recommendations and lessons learned for answering those critical science questions at the South Circumpolar site expected for Artemis. Next chart, please. The next session we had was volatile. Samples and volatiles were held on back-to-back days. And the report from the volatile session touches on characterizing and sampling polar volatiles. So it provides some information about operational activities to characterize and sample volatiles, as well as touching on sampling in both permanently shadowed regions and in illuminated regions. It touched on the importance of characterizing outgassing from humans and the implications for contamination for the lunar environment, as well as for the science resulting from those samples. And it really did a nice job of highlighting the need for an integrated strategic campaign to really address these critical science questions, while also highlighting 5 key characteristics for understanding and operating in this unique polar environment, which include temperature, illumination, terrain, the electrical environment, and unique implications of the volatile environment. Next chart, please. The lunar dust and regolith session taught me a lot about a topic I didn't know much about. The report did a really nice job of raising immediate and kind of short-term questions that we need to answer about lunar dust and regolith. Dust and regolith is interesting scientifically, but it also could have a big impact on hardware and engineering constraints. So the session touched on all of that. It talked about the physical properties of dust and regolith, the interaction effects of kind of interacting in that lunar environment, implications for collecting samples of this unique material, and any possible dust charging that would result from interaction with the lunar dust and regolith, and any need for exclusion and mitigation resulting from this interaction. And it highlighted a few key early Artemis objectives, like characterizing fine-scale polar regolith, characterizing the impacts of the lander plume on the natural surface, characterizing the natural dust and plasma environment found on the lunar surface, and talking a little bit about the need for material sample return in addition to lunar sample return. Next chart, please. The Planetary Protection and PSR Classification Workshop talked about some primary issues we need to think about right now to inform policy for planetary protection, talked about quantifying contamination, understanding the really unique environment found at the poles and specifically in shadowed regions. I talked about understanding and modeling exospheric transport at the lunar surface and how any geologic features we see on the lunar surface can mitigate this possible contamination of these really critical regions. And then it actually had a few discrete sections in that report that highlighted some really important issues. And this report is a particularly good resource, I think, for looking at planetary protection and any sort of outstanding questions associated with these planetary protection issues. Next chart, please. The Science Enabled by Mobility session, we're up to October 2020 now, talked about science that can be enabled by semi-autonomous robotic rovers and the priorities amongst this science. You have, of course, broad scientific exploration and systematic mapping and exploration, the ability to deploy and retrieve and even service instruments, the ability to just amplify the amount of science that can be done during the crewed operational phases as opposed to the uncrewed operational phases, engineering science crossovers, the implications of crew autonomy, linking traverse execution to science questions. And then the workshop also touched on science enabled by uncrewed but crew capable rovers. We heard a lot about from the headquarters presentations about this ability to supplement crewed exploration with uncrewed capability. And this report dives into the types of capability that these robotic assets should have to enable that exploration. Next chart, please. Foundational data products made recommendations in 2 key areas. For surface characterization, it talked about how to calibrate and improve the data products we have, how to look at an orbital platform for monitoring this environment and identify key surface areas for exploration. And in resource characterization, it talked about developing a classification scheme. It talked about the need for drilling and trenching and the need to characterize things like porosity in the South Polar regolith to understand volatiles. Next chart, please. Up to January 2021 here, the space biology session taught me a lot, and there was 2 days during this workshop that had 5 breakout sessions focused on vertebrates, invertebrates, cell biology systems, microbiology, and plant biology. Talked a lot about how the space research we're talking about today, the ground-based research and LEO research, are complementary to the deep space research going on. Talking about sample preservation and return on and from the moon that you heard Kevin talk about earlier. Talked about bioregenerative life support. Again, you heard Kevin answer a question on that earlier. And also talked about future work and how we can use that effectively to answer our outstanding questions, which you saw in several presentations were highlighted in the Science Definition Team report and our major Artemis science objectives. Next chart, please. The most recent LSSW session before the one today, obviously, is structuring real-time science support of Artemis crewed operations that took place over 2 days. We talked about leveraging lessons learned from programs like Apollo, Mars exploration, ISS, and Space Shuttle, as well as analog missions, and highlighted key lessons learned that we needed to translate into Artemis mission planning from those really successful programs that had great science return, and also provided recommendations and outstanding questions for 2 key areas for science operations support: infrastructure and architecture. So I encourage you to check out, these are just a couple of the many recommendations and outstanding questions in infrastructure and architecture. Next chart, please. So here we are at LSSW number 9. You heard Sarah talk earlier about the next few sessions we have planned, but they've been really successful so far in gathering community input and promoting dialogue with the community. And we look forward to continuing and keeping that ball rolling for future workshops. And a final plea, there are 5 draft reports up online at that website, and I really encourage you to go and provide those community comments. You'll see an email shortly soliciting that feedback with a deadline for making your inputs. Thank you for all of you who have attended and engaged so far. We on the organizing committee have been thrilled with the level of engagement, and we're looking forward to a lot more of it moving forward. Thanks, Deborah.
Thank you, Kelsey. Excellent summary. And you made it on time, so you can take a breath now. That was a lot to cover in not very much time, so that's fantastic.